All right. Cool. You guys can have your snack while we work quietly. Okay, so going back to what we were doing, properties of multiplication, we've talked about the commutative property. That's where you can flip-flop the factors and you're still going to get the same answer. We've talked about the zero property, which is anything multiplied by 0 is going to be 0. We've also talked about the identity property. Anything multiplied by 1 is itself. And now we are moving on. Kinsley says that she thinks she knows another one of them. Yes, Kinsley?
Distributed property, can you break them apart if it's like 3 numbers that you break one number into one
By?
You break apart one number and then you add that number carefully and you times out 2 numbers.
I think you're on the right track. So she's talking about the distributive property, okay? The distributive property means that you can break apart one of your factors. So probably the bigger one, break it apart into 2 numbers, and then multiply those smaller numbers by the other factor, and then add those together to get your answer. And it's going to be the same answer than if you multiplied it to begin with. Okay? Just the way it was. What, Cristiano? You're not supposed to. You're supposed to bring it in the morning. Go ahead. All right. So, for this one, the rule is you can get the product by breaking down a number, or I would say by breaking down one factor into 2 numbers and multiplying both of those by the other factor. Okay? Example. Seven times 9 is the same thing as what's 2 factors or 2 add-ins you can break 7 into? Bryn? 5 and 2. And you could take those 2 numbers and multiply them both by 9 instead of just doing 7 times 9. And then you can add those together. So you have 5 plus 9 and 2, I'm sorry, 5 times 9 and 2 times 9, and then you add those together, and that would equal the same thing as doing 7 times 9. Why would you want to do that, though? Why would you make 2 problems instead of 1, Abby? It might be easier to multiply. So if you're thinking about a bigger number such as 13, so say it was 13 times 9. Well, maybe we don't know 13 times 9 in our head, but do you know 10 times 9? Do you know 3 times 9? So breaking that 13 into 10 and 3, you can do 10 times 9 and 3 times 9, and then add those 2 numbers together to get your answer. Does that make sense? Okay, so that is the distributive property. Now, does anybody know the associative property? All right, so the associative property is very similar to the commutative property. The only difference is that it's talking about you can change the order of grouping. So basically it's the commutative property, but if you have parentheses in it. Okay, so looking at the associative property, the rule is when the grouping of the factors is changed, the product stays the product is still the same. Example. So say you have grouping like this. It doesn't matter whether you change where the parentheses are, no matter where you put them, as long as it's all multiplication in there, it doesn't matter where you put the parentheses, you're still going to get the same answer. So you could put them like this, and it would still be the same answer as this. And you'll find out as we get into expressions that parentheses means that you solve that part first, according to the order of operations. But we will refer back to this for as long as we do multiplication. So you may not use the associative property right now, but you will throughout the year. Okay. All right. Once you have all of that, let's see, how much time do we have left? Let's stop there and we're going to move on to science. Tomorrow we'll talk a little bit more about the properties of multiplication before we start doing some actual multiplication. So we're pulling out our science journal. In your science journal, we already did the matter brain dump, right? Okay, so I'm going to put this away. I'm going to pull out my science journal. And we're going to talk about some of the things that you wrote. Okay, so if you want to share something that you wrote for your matter brain dump, that should have looked like this. And remember, a brain dump is just where you dump everything on the page that you already know about matter or about whatever topic that the brain dump is about. All right, Alex, what did you put? Solid, liquid, gas? Whoops. Okay, so solid, liquid, gas. Anybody know the fourth form of matter? We're not going to talk about it this year, but it's just kind of cool to know. Bryn?
Plasma.
Plasma. There's a fourth state of matter, but we don't talk about it in 5th grade. Yes, Anthony? Matter takes up space. Matter is anything that takes up space. Kinsley? So that would be a misconception. So matter is made up of atoms, which are so tiny that you can't see them with your eyes. But matter you can see. Matter is me. Matter is you. Matter is this planner. Matter is this desk. You can see matter all around you. So I would correct your misconception there and say matter is everything you can see. Gianna? Has mass. Yep. Anything else? Matter? Leah? Same thing. Rylan? So you're talking about how dense it is? So like, yep. Okay, so he's talking about the atoms. The more dense something is, the more, so if it's like a solid, it has more atoms, whereas a gas would have more spread out atoms. Okay. Morgan, sorry, I blinked for a second. Volume, okay. So it can have volume. Anything else? Bryn?
I wrote some stuff down, but like that I remembered that like somewhat matches up with matter. I put forces like push and pull and friction.
Okay. Yeah. I mean, you do those things with matter. What about like properties of matter? Like things about matter. How do you observe matter? You find the mass, the weight. What else? What else would be a property of matter? Rebecca? No, that would be like a state of matter, yes? Are you raising your hand if you don't know the question, silly? So we're talking about properties of matter. How can you describe matter? You can talk about the color, texture, size, hardness, right? These are all things that can describe matter. What about changes in matter? What kind of changes are there? Zaid? There's physical change. Leah? There's chemical changes. Anything else we know about matter? Christiana? Okay, like thickness, density. All right, so you don't need to have everything I have. This is just your brain dump where you put your information. But we are going to start with a video. All right, 1 second. I have to reshare my screen. The sound. Oops.
Can't solve cube puzzle. Getting angry. Tim and Moby. What are mass, volume, and density? And why are they important? Love, Kira. Mass, volume, and density are all physical properties of matter. Matter is anything in the universe that takes up space. It makes up everything that you can see, feel, taste, or touch. And mass, volume, and density are measurements that we can take of material objects. Why do we measure stuff? Well, basically to understand it better and to compare it to other stuff. For example, we measure time in hours, minutes, and seconds. Can you imagine if we had no way of measuring time? We wouldn't know when to go to school, when to come home, when the next episode of Battlestar Galactica was on. And if we couldn't measure the mass, volume, and density of objects, we'd be just as confused about what they are and why they act the way they do. Right, measurements also help us standardize stuff. In the science lab, we use the metric system for all our measurements. Its basic units are the meter for length, the liter for volume, and the gram for mass. Because the metric system is used all over the world, scientists everywhere can compare their discoveries and ideas without too much confusion. Now, let's measure this cube. We'll start with its mass. Mass is a measurement of how much matter an object contains. In a lab, we measure it with a balance or a scale. Let's see, the cube's mass is about 250 grams. Well, weight is different from mass. Weight is actually a measure of the effect gravity has on an object, and it's measured in newtons, not in grams. For example, on Earth, this cube weighs 2.5 newtons, but on the Moon, where the gravity is only 1/6 as strong as Earth's gravity, the cube only weighs 1/6 as much. No matter where it is, though, the cube's mass is always the same, 250 grams. Now to volume. The cube's volume is a measure of how much space it takes up. Since this object is a solid, the volume is measured in cubic centimeters, and you can calculate it by multiplying its length by its width by its height. Well, liquid volume is measured in liters. 1 milliliter takes up the same amount of space as 1 cubic centimeter. And while it's easy to measure the volume of a cube, it's a little more difficult with an irregularly shaped object like this pebble. Matter displaces liquid, and that's a fancy way of saying it takes up space. If you can measure the amount of liquid that the object displaced, then you've found the volume of the object. Before we dropped this rock into it, the water had a volume of 50 milliliters. After we dropped it in, the water level rose to 70 milliliters. So we know that the pebble has a volume of 20 milliliters, or 20 cubic centimeters since it's a solid. Density. Density measures how heavy something is for its size. Are its atoms packed close together or far apart? We can calculate density by dividing an object's mass by its volume. Let's see, the mass was 250 grams, and the volume was 1,000 cubic centimeters. 250 over 1,000 is 0.25. So the density of this cube is 0.25 grams per cubic centimeter. Pretty impressive, huh? Okay, now you're just showing off.
I absolutely love teaching. I just wish I had more time to prepare fun lessons, especially.
So we are going to be getting our new notes packet. So what I tell everyone to do during this time when we are changing from one unit to another, you are going to be keeping your notes packet in the clear sleeve that's already in your binder. So you have to take your old notes packet, your old study guide, your old vocab cards, and you need to either move them to your binder, your science folder, your backpack, but I would not throw them away. Those are excellent tools for studying for FSA. So if you have a place, an open folder, an open place in your binder, or if you just want to move them to your backpack to keep at home, that would be a great place for those. And I'm going to be passing out the new notes packet. now you're just clearing out your sleeve so that you can put it away when we're done. So you'll need a highlighter and a pencil. We're going to start our notes packet. Yeah, you can put your journal away for now. All right, you should have that in front of you. We're not talking. All right. Does somebody have my science notes packet? Oh, wait, I found it. I got it back. I mean my old one, my one from the last unit. All right. So you should have a highlighter and a pencil. Blank is anything that has mass and takes up space. Solid, liquid, or gas. Aubrey? Matter. Blank is the amount of matter an object contains, which is measured with a balance or a triple beam balance in grams. Rebecca? Mass. All right, the law of conservation of mass. The mass of the whole object is blank as the sum of the masses of all its parts. So what does this mean? This means if I take an object such as trying to think of something easy. So if I take this textbook, okay, and I rip it into pieces, I take the pages apart, I rip it all into pieces, and then I set it next to it. Okay, so I've got all the pieces together in a pile. That pile would weigh the same as this whole textbook when it was put all together. Does that make sense? So it doesn't matter if you break something apart, even if it's in pieces, as long as all the pieces are still there, it's still going to weigh the same amount. That is the law of conservation of mass. Okay? So the same as the sum. What is the sum? What is sum? S-U-M, sum.
Like the answer that you get or something.
Not something. Alex? When you add something. The answer to an addition problem. Product is the answer to a multiplication problem. Sum is the answer to an addition problem. All right. So a roll of quarters has the same mass if it's in one piece or if you break it apart. Yes? What? Oh, the next one? Blank is the measure of the pull of gravity on an object, which is measured with a spring scale. Nope. Cristiano? Nope. Rebecca? The measure of the pull of gravity on an object, measured with a spring scale in grams. The next blank. Kinsley? Lila? Huh? The weight. Just the weight. So the mass is the amount of matter in an object. The weight is the measure of gravity on an object. Objects that have more mass also weigh more. The more mass you have, the more it weighs. Okay? Blank is the amount of space an object takes up. The amount of space an object takes up. Leah? Lila? Volume. All right. Okay, so we're going to stop there in the notes packet. We are going to do something with this tomorrow. Take out your journal because we're going to put together the foldable that we're going to be doing tomorrow. So I'm just going to put it together so that it'll already be made for tomorrow. Okay, it's going to be called Properties of Matter, page 15. Your notes packet goes directly into the clear sleeve in your binder so that you always have it with you. I had so many parents tell me, my student does not have their notes packet. They don't even know what that is. That's crazy to me considering we We write on our notes packet almost every day.
I don't have mine.
Paper passage.
Push down.
Split that in half. Just give him 1/2 of it. All right, and then you're just simply folding this like a book. You will have to trim it a bit, most likely, so that it will fit under the I can statement. So I'm gonna trim just a little off so that it fits nicely under the I can statement. And then I need 5 flaps. To make 5 flaps, you have to draw 4 lines.
Does it have to be perfect?
Nope. So you need 5 flaps, so you make 4 lines. Then you cut your flaps. Remember, when you cut flaps, you only cut the top page, not the bottom. All right. Yes. I said we have to trim it to make it fit. I'm just letting you guys read this before I start putting the titles on. Okay, so it should say physical properties of matter, and then you have 5 flaps, and then I'm going to go ahead and glue it in and title the flaps, and then we will have recess. Yep, we're going to glue it in, we're going to put titles. Yes. Guys, you know that anytime I use markers, unless I say for sure you need to use color, you don't have to do the same thing as me. You can just use your pencil. I'm gonna move it up in a minute. All right, once you get your titles, Kinsley, there's no way you can be done because I didn't show the last one. That's as much as using. All right, once you get the titles and it's glued in, you can put it away and clean up for recess. You need to have your RTI folder on your desk. No, we're not going outside. All right, once you get that foldable made, you can look at the video tomorrow to know what we will be writing in it.